Well, hello Internet and welcome to my ECMAScript 6 tutorial. In this one tutorial, I'm going to cover about 85% of what you could read or learn about ECMAScript all in one video. And like always, all the code as well as a transcript of this video is available in the description along with timestamps that are going to allow you to click to learn exactly what you want to learn. Now, ECMAScript was originally based on JavaScript, and now JavaScript basically models ECMA. So it's a very important technology to learn about. And it's used mainly on the client side, but also on the server side, of course, just like JavaScript. But I'm guessing you know all that, so I'm not going to waste your time. And I have a lot to do, so let's get into it. Alright, so on the left here, I'm using Atom, and this is all the HTML we are going to be using here, and this is going to be our script file right here, and on the right, I have Google Chrome, and I'm just going to be typing stuff in here and loading it over there. The name of this file is ECMAScript.tut.html, but you can name it whatever you'd like, and just as long as you link to the script file that has all of your code. Alright, so the very first thing I'm going to talk about is let. Now, you probably are used to using var, and how let differs from var is if you use var to define a variable, that variable is going to be available globally versus let, which is going to make the variable available only in a block. And I'm going to show you here an example of how this is going to work. So let's say we go and we create a variable inside of here, and then we want to print that variable value out, and then we come down here and we go to try to print that out. So now let's reload it. And you can see in this situation that 10 prints out both times. However, and that's because it's global. X right there is global. Now let's change this to let and see how that changes. And reload it. And now you can see that X prints out inside of here, inside of this block. However, we get an error down here that says reference error, X is not defined for this guy right here. So that's the basic idea behind using let instead of using var. Another thing that's important to know is, and the reason why that's a very good thing, is that you're going to be able to use non-global variables, and global variables normally cause all kinds of havoc because you don't know where they lie in your code, and all of a sudden file values or variable values change, and then it causes chaos. So it's much better to use let, and throughout the course of this tutorial, I'm going to pretty much always use let. Now, another thing that's very important is we can go inside of here and we can define another variable. And then we can say, if true, once again, we want this to execute every time, and we can go let y is equal to 20. So here we went and used exactly the same name for our variable. However, if we come down here and print it out, you're going to see that it's going to be safe and it is not going to mess up our code. And document write's going to get a lot prettier here in a moment. So you can see right there that y still has the value of 10, which is defined up here because let didn't change anything. So that's the basic idea of let. I'll get a little bit more into it as the tutorial continues, but now I want to talk about constants. Now, constants, of course, allow you to define a constant value that cannot be changed, and how you do it is just like this. So we can go in and define pi, and we can go and give it a value. And if you do so, you would then, if you would go in and say, no, I want pi to be equal to 2.13 instead, you're going to see that that indeed is going to give you an error. See, error down here. Just trust me. Bad thing. Don't want to do that. However, let's go and define a block inside of here. And let's define another constant. And let's put pi inside of this block. And now let's try to change the value for pi inside of here. And if we do so, let's go and do that. And let's change this to pi instead and change this to pi right here. You're going to see that we are able inside of those blocks to define constants without messing anything up. And there you go. All right, so pretty cool stuff, and that's the basics of constants and how they work. And now I'm just going to do a real quick example of the different data types that are available with ECMAScript. Now, you still don't declare a data type, but instead the value is defined based off of the type or the value that is assigned to a variable. And the main types inside that are available to you here are going to be Boolean, number, string, object, and symbol. And you can see here I use type of to basically figure out what all these different data types are. and you can say that they automatically work, and there is a Boolean true. You can see here is number, so there's no doubles or floats or integers. Everything's just a number. There's a string. This is a symbol. We'll get more into symbols later on. These are going to be objects, even though the array right here is going to also be considered an object, and undefined is also going to be undefined. If you want to use data types, you can go and use TypeScript, which of course I have another tutorial on, but that's just a basic overview of the different data types that are available to you. And now I'm going to take a look at strings. Now, something that's really cool with strings now and with ECMA is you're going to be able to use string interpolation using what are called template literals. So let me give you an example of that. So we'll say we have a first name, and I'll just pick something out of my head here, and we will also throw in a last name, and there we go. Now let's go and show you an example of what a template literal looks like. I'm still going to use document write just like I did previously, except I'm going to get rid of all of this stuff. Well, let's keep that little guy right there. And then what's really cool about it is I can do this, which is the back quote like that, and throw another one in here just like that. And what I'm going to be able to do is go and throw the variable directly inside of there, which makes your code so much neater. So we can go fname and last name like that, and save that, and keep the break statement directly inside of there, and reload the screen, and you can see that it goes and prints out the name directly right there. So it makes it much easier, and we're going to be able to do all kinds of other cool things with it. Once again, template literals is what these are called. Another example of what we can do here, and copy this, is let's go in here and let's define two numbers and give that a value of 10, and let's go and define another value inside of here and give that a value of 5, and let's use the template literal again. We can now come in here and throw something like 10 times 5 is going to be equal to, and perform the calculation directly inside of here. So num1 times num2, directly like that, and reload it, and you're going to see it does the calculation directly right there. So it keeps your code much neater. You're also going to be able to use what are called tag template literals to modify output using a function. So let me give you an example of that. I'm going to come in here and define a function, and I'm going to say do math is the name of it, and it's going to be passed in strings, and I'm also going to go in here and put 3 dots and values. And in this situation, this guy right here is going to be a string array that's going to contain all of the strings inside of here. And then you're going to have your values array is going to contain all of your substitutions. Let me give you an example, and then you'll see exactly how this works. So what I can do now is I can say if strings and reference that string array, and right like this, it breaks apart everything inside of there. So let's say I go add, and then I can say that I want to do a document write and change all this, and go values, and grab the first value that was passed inside of here, plus, and then values again, and grab the second value that was passed inside of here. Whoop, don't forget to close this off right there, and get rid of this extra straggler, is equal to, and then we can perform our calculation directly inside of there. So we'll say values plus values, and get the second item out of there, and perform that calculation. Otherwise, what we can do is say else if strings 0, we're going to be grabbing the exact same thing, a string, and we'll do subtraction like that. In that situation, we're going to perform a subtraction. So we'll say minus, and then change this to a minus sign. And now what we can do that's really cool is come down here and say do math, and pass inside here, using back quotes once again, the string add, and then 2 values inside of there. One of them being 10, and the next one being 20. And then we could do exactly the same thing. Once again, let's do math, and we'll throw subtraction inside of there once again. And then there's no spaces between the sub or the add and the $sign. And we could put spaces inside of there. We're just going to have to change the value of strings that we're working with and the value of the values. Throw another space inside of there and throw in 20 again. And then we come out here and reload it. And you can see that it was able to go in there and grab the values as well as the strings and be able to perform the right calculation depending upon the information that's there. Play around with this. Very, very cool. I'm not going to spend a ton of time on it, but very, very cool and a really awesome addition to ECMAScript. We're also going to be able to iterate over characters. So let's go, let's see, of fname, do a document write, and then inside of here, I'm going to throw a C inside of there, and then just get rid of everything else here except for my break statement, and reload it, and you're going to see it iterated through all of those different characters in our string. And fname, once again, comes from this guy right up here. And once again, I'm talking about strings here, not just template literals. We're also going to be able to come in and repeat a string, another capability we have. So let's say I wanted to print out hello a whole bunch of times. I could do so. So let's go in and go hello. And then at the end of it, say repeat and 3. And then we'll add in this guy. And it goes hello, hello, hello. We can check if a string starts with a specific value. So let's go in and say something like fname and see if it starts with, and then throw in a value, DE for example. And let's do a couple more here. We can also check if it ends with a specific value. So let's change this to ends with, and we'll throw in EK here instead. And we can also check if it includes, just by typing in includes. And then we could throw something like ERE. Just anything inside of there. And you can see that they all come back as true. Let's do some more. You're also going to be able to create multi-line strings. So we can go and create this guy is equal to, and we're going to throw double quotes inside of there. And then we're going to say something like this is, and then to make it multi-line, you're going to do a backslash and go a multi-line. Once again, another backslash and string at the very end of it, and you don't have to put a multi-line obviously. And then we can come in here and actually print this guy out. Once again, I'm using back quotes here, and then I can print out the multi-line string. There it is, and put the str inside of there and reload it, and you can see it printed there. And another thing you can do is get rid of these backslashes altogether. You can see it's giving me an error. Well, that error is going to go away right now. Put in your back quotes, and then get out of there and throw in another one and reload it. And you're going to see that it still works. So there you go. Whole bunch of new things that are available to you string-wise. And now I want to show you a whole bunch of things that are different in regards to functions. Now, if you want to use default values, you're going to be able to do that. So let's go and let's create a function, and let's call it getSum. And it receives a number, and I want to give it a default value of 1. And then let's go and create another one, and let's give that a default value also of 1, just for the heck of it. And then inside of document right here, I'm going to go and print that information out. So we'll go num1 plus num2 is equal to, and then we'll go and perform the addition inside of here. So num1, num2, and then we can say getSum and throw 3 inside of there like this. And you're going to see that it's going to come back with a value of 4. Why? Because the 3 took over this space here, but the 1 remained right like that. Another thing to know is the arguments array is only going to receive the value that was passed into it. So let me give you an example of how that is going to affect things. So here we can say arguments and then go plus, and here, and once again, arguments and 1. Normally you would get this one and this one, but you're going to see how that changes here and reload it. Here you can see that it does not take the value here for, in regards to the arguments array, for the defined value, only the value that was passed in. Okay, so it's something very important to be aware of. Rest parameters, which are going to be preceded by 3 dots, are going to become or be treated as an array. So let's go and give you an example of how that's going to work. So let's call this getSumMore and create a rest parameter. And here I'll say values. And then let's define a sum inside of here. And let's cycle through this guy. So we'll go let I is equal to 0. And then length is going to be value length, while I is less than length. I'm going to increment the value of I, and then sum these values up. So sum plus equals 2, and each of the individual values inside of the values array. Come down inside of here, print that out. So we can say something like the sum is, and then print out that sum. And then we can come down here and go get some more. And this is just a way to pass in values. You can either use arguments or you can use rest parameters here. There we are. A bunch of values passed inside of there, and reload it. Forgot to put the S right there. Save that, reload it, and now you can see the sum comes back as 10. You're also going to be able to pass arrays, and let's see how that works. So we'll go let vals is equal to, and let's go and create an array inside of here. And then let's call get some more, and then pass that inside of there. And here you can see that that all adds up. Arrow functions are going to define parameters followed by the body of a function. So we'll say let, and we'll call this difference is equal to. Here what you're going to do is you're going to define the parameters first, pass to a function, and then you're going to put an arrow inside of there. That's why they are known as arrow functions. And then here what you want to have done to them. So we'll say num1 minus num2. And then let's print some information out. Here we can say 5 minus 10 is equal to, and then call difference, and then pass into difference 5 and 10. And there you can see that comes back. It's very important to know that you can use arrow functions, however, and have more than one statement. So let's go mult is equal to, and num1 and num2, throw an arrow function inside of there, and then just use curly brackets to use more than one statement. So we can say let product equal to num1 times num2, and then do the document write directly inside of there. And we can reference that file times, and then num2 is equal to, and then we can throw product inside of there. And then inside of here, we can then call our function, of course. So mult 5 and 50, and there is our answer. Another thing that's really cool is you're going to be able to use arrow functions with map, filter, and reduce. So let's go and create another array, and let's just call this value array, and just throw some values inside of there. Reduce is going to apply a function against an accumulator to get a single result. So let's say I want to sum all these values. I can do so. So let's say sum values is equal to value array and reduce, and here A and B, we're going to take in 2 values at a time from our array, and we're going to add them until no more exist. And then we can print out our results of that. So we'll just say sum and sum vals, and I also said that we're going to be able to use filter. Filter is going to return those values that pass a condition. So let's say that I just want to get the even values. I can say evens is equal to value array and call filter on it. Once again, the arrow function. And here is going to be the condition. It's going to be if the value of the modulus of 2 versus each of the values inside of the array as I cycle through them comes back as equal to 0. Well, then we know that it is an even value, which means that it's going to go into the evens array. And then we can print that information out. So we could say evens and then evens. And let's also show you an example using map. So here with map, let's say we want to, basically map is going to perform the given action on every single item that it's passed to it. So here, let's say I want to double every single thing inside of there and then save the results. Value array once again, and call map on it. And what I want to do to every single item inside of there is multiply them times 2. And once again, we can come in here and print out our results. So we'll say doubles and doubles. Whoops, throw a curly bracket in there. You should have told me about that. Throw a semicolon in there instead. What was I thinking? Get rid of that, reload it, and here you can see reduce went and added all the values inside of the array and saved them into some values. Evens went and performed this condition against every single value, created a brand new array called evens, and only stored even values inside of it. And map down here helped us double every single item inside of the array. So there's a rundown of some of the new capabilities provided to you with functions with ECMAScript. And now I'm going to talk about objects. Now you're going to be able to create what are called object literals like this. So we'll be able to go in here and say function and create animal. And let's say that every animal is going to have a name and every animal is going to have an owner. We could then say return, and then inside of here define our properties. So we'll have name, owner. We can of course come in here and create a method like getInfo. It's not going to get any parameters passed to it. And it is going to return, again, back quotes, name. Have to use this name, which is a way of referring to the object specific name, because we don't know what its name is, because we create this definition of what this animal object is going to be before we ever define a name. So owned by, and then we can go and get what is owned by it with owner. Once again, put this inside of there. And also we are going to be able to have objects inside of this object. So let's say we want to define an address for this guy. Go and create a new one. And we'll say that this specific animal is going to be at 123 Main Street and city. Let's say that every single animal is going to be in Pittsburgh on Main Street. We can do so, and we'll close that off with a semicolon. Now what we're going to be able to do with that guy is let's go var spot is equal to, and let's call create animal, and let's pass inside of it spot, and we'll say that spot's owner is going to be a guy named Doug. We can then go document write, and we can call the getInfo method we defined inside of here by referencing spot and getInfo. We can then also access the objects inside of our objects. So let's go do this again, and we will go and get spot's name. So spot name is at, and then access the object inside of the object. Remember, we defined everybody lives in the same place, so we'll go like this. And then you just go address like that. And if you want to get the street, you just do that and reload it. And you can see spot is owned by Doug and spot is at 123 Main Street. Another thing that's kind of interesting is we can get the properties and methods of an object just by coming in here and saying object and get own property names, and then pass in what we want. So that's going to be spot in this situation. And then I want to do a join and then separate everything that comes back with a space, and then throw in our $sign and our curly bracket like this. And this is get own property names like that. And you can see that all of them come back right there. You're also going to be able to store values from objects using something called destructoring. So let's go and define that. We'll say that we want the name and the owner that is stored inside a spot. We can do so. And then I'll just grab the name out of here like this. And there you can see we grab spot. We can also get an inner class value. So we'll say let, and then we'll go address equal to spot, and then get our address value out of there. And how we would do that is reference address and street specifically inside of there. And there that is. Something else that's neat is we're going to be able to destructure arrays. So let's go and create a favorite numbers array and throw some random values inside of there. And let's say that I just want to get to the last one of them. I throw in 2 commas like that. And let's say I want this to be called chaos and pull it from favorite numbers, of course. And then if I want to print that out, I can go chaos and chaos, of course. Pretty cool. And of course, if you want any of the other values, you just put them in there instead of just the blank quotes or the blank commas. You're also going to be able to use rest items to grab part of an array. So to do that, we go let. We'll throw a comma inside of there. And so let's say that I want to get the last 2 items and save it into an array called last2. Pulling that from favorite numbers again. And then let's say that I want to get the second of those items. So we'll say second num, and then we'll go last2 and get the 0 index out of that. And another thing that's neat is we're going to be able to switch values. So let's say we go let value 1 is going to be equal to 1 and value 2 is going to have the value of 2. We can then come in and go val1 and val2 is going to be equal to val2 and val1. And that's going to switch the values from where they were previously. Very, very nice and neat. And then we can just go and grab val1 here just to prove that it worked. And you can go grab val2 if you do not trust me. So we can go like this, and val2, and we know that it's supposed to have a value of 2. However, since we switched it, you can now see it has the value of 1. Okay, so pretty cool stuff you can do there. Now I want to dive deeper into what we can do with classes. Now, classes are going to work much like they do with other languages. So let's come in here and let's define a class. And let's create a constructor for the class. And we're just going to define that this is going to receive a name by default. And you're going to use this, once again, to refer to the objects you create. However, you're going to protect this information by using normally an underscore followed by the normal name, that whatever the variable name is, like that. And that's all we're going to do with our constructor right now. And we can also use getters and setters, and to do so you just go get and name, and of course this could return some custom value or some custom version of our name. And again, you're going to use an underscore. And then you can create setters as well, and you're going to do exactly the same type of thing here, except you're going to receive a name that's going to be changed. And then once again, we'll use this and save whatever value was passed inside of here. Okay, and you're also going to have the ability to use static methods, and so we'll just create one here, and this one is actually going to create mammal objects and pass them back, and it's just going to receive a name. And to go and create a mammal object, you just go new and mammal, exactly like that, and then pass the name inside of there, and the constructor will take care of the rest. And also we could have just regular old methods inside of here. So we'll just do get info, and the whole point of this is that it's going to return a string with all the information about our object that we create. So I'll just go this, and here I can say name is a mammal, and there we go, and that's going to return it. And we can come down here and then go and test out this stuff, see what happens. If we want to create an object, we can say let monkey is equal to, and then new and mammal, all uppercase of course, and then you could pass in whatever you want your monkey to be called. So I'll call this one Fred. We can also change the name, and to do so, we just go monkey name, no underscore of course, and throw in Mark. And we could also call our getter, and here we can just say mammal, and then get our value for our monkey. And again, we just use the name. We don't use an underscore prior to that. We can also come in and create a mammal using our static function. So let's go chipmunk. And to call our static methods or functions inside of here, you're going to precede it with whatever the class name is. So here I'll go mammal, and then I'll call for make mammal, and then I'm going to pass in a name. So let's call our chipmunk chipper, and let's print out some information about that. So let's just call this mammal2, and then we will call chipmunk followed by the name. And I haven't run any of this, so we can see what that looks like. You can see right here, mammal, and we received the name for it, which is Mark, and mammal2, which is Chipper. So you can see that we are able to create objects that way. We're also going to be able to come in here and inherit all the properties and methods with extends. So let's say I want to create something called marsupial. I think I spelled that right. And to get everything from the mammal class we created, we'll just say extends mammal. And then we can create a brand new constructor for this guy. And let's say that our marsupial objects are going to have names, and also they're going to have a boolean, which is going to be whether they have a pouch or not. Somebody out there might know more about marsupials than I do. I don't know that they all have pouches, and I'm going to put that in there. If we want to call the super constructor for our mammal class, we just go super, and it runs that, and it's going to take care of the name, setting up the name, and then we'll have has pouch be inside of here, because that is special to our marsupials. And so there's has pouch. And we can come in and define getters for has pouch as well, and we will, of course, just return this, and then we will have an underscore in has pouch, and we'll create a setter as well for has pouch. It's going to receive the true or false for has pouch, and then we will store that has pouch is equal to whatever true or false was passed into it. We're also going to be able to come in and override methods just by providing the name and then more or additional different information, and it automatically overrides it. So here we can say return, and then we can say this name is a marsupial. And now we will use this marsupial class to create a brand new object. And I'm just writing this out of my head. So kangaroo, as far as I know, kangaroos are marsupials. And so let's just go and create them. So marsupial and Paul. And we will say that that is true. I do know that kangaroos have pouches. Positive about that. And let's go and get some information here. So let's go, it is, and we'll say kangaroo has pouch, that, and let's go and get kangaroo once again, has a pouch. We'll see how that works out for us. We also can come in and test the overridden method. So here we'll go in and we'll just go like this and chipmunk and get info. And don't forget to put those parentheses inside of there. And then we're going to do pretty much exactly the same thing just to test this out with our kangaroo. So we'll change chipmunk to kangaroo. We're also going to be able to dynamically inherit from classes, which is something kind of neat. So we can say get class and class type. And then here we can say if class type is equal to 1, then we want to return a mammal. Else we will return a marsupial. So that's kind of neat, something that ECMAScript does that isn't very common. And then we can come in and test this with class, and let's create a koala, and let's have it extends, and then we will call get class on that and pass a 2 inside of it just to test this out, and create a new constructor that receives a name, and then we'll just call the super name like that. And then we can come in here and test this. So we'll say something like let and Carl is equal to new koala, and give him the name of Carl. And then let's print out some information about this. So we'll say Carl and get information. And if we run that, we didn't create any errors. It looks like it's going to work. It is true that Paul has a pouch, Chipper is a mammal, and Paul is a marsupial. And those, of course, come from these guys up here. And I have a little bug down here, and that's because I didn't put a capital M right there. So let's save that and reload it. And now you can also see that Carl is a marsupial and that we were able to create a dynamic class with our koalas. So pretty cool stuff. And now I'm going to jump over and talk about symbols. Now, a symbol is going to be kind of like an enumerated type that can be used as an identifier, and they can't be changed, which means they are immutable. And to create a symbol that is used like a label in an array or something like that, you can provide a description in quotes, but it's only really there for debugging purposes. So let's say we want to go capital, and let's create a new symbol. And this is what I'm saying about putting in a description. So I'll say something like state capital, and then let's use it. So we'll say something like let Pennsylvania, and let's create that object like this. And then we'll go Pennsylvania, and then we'll use capital like a label, just like you can see there. And we'll put in Harrisburg. Save that there. We can now come in and go document rights, and we can say capital of PA, and then inside of here, get rid of that guy, and go Pennsylvania, and capital, and I spelled Pennsylvania wrong, not a good thing to do, Pennsylvania, and you can see capital of PA comes back as Harrisburg. So let's go and do a couple more things here. We can actually come in here and get the description that we have saved for this. We can say symbol, capital, and then go capital to string. And there you can see is the information on along with the description for our symbol we created. You're going to be able to share symbols by using symbol for. So we'll go let employee number. So all employees are going to have a number. So let's share those symbols. So we'll go symbol for, and this is going to be employee number. And then we'll be able to go and Bob Smith, and let's create this object here, and then go Bob Smith and use the employee number, and we'll go and give him an employee number of 10, and then we're going to do a similar thing with another one. So we'll go Sally Marks, throw that in there, and then use that symbol again, Sally Marks, and employee number, and make her equal to 11. And then output this information. So we can just go Bob like that, and then Bob Smith, and then throw the employee number inside of here, and then do pretty much exactly the same thing for Sally Marks. So we'll just go Sally, and then this is going to be Sally Marks. And there you can see it popped both of those out. So there's a rundown of symbols, and now I'd like to take a quick look at arrays. So let's go and create an array. I'll just call this array1. And you can use array of to create arrays instead of the normal array constructor you might be used of. So we'll just go array of, and 1, 2, and 3 is going to be our array. We'll also be able to change an object into an array. So we can say let array2 equal to, and you're going to go array from to be able to do that. We could use a string, for example. We're also going to be able to use array from to manipulate values. So let's go and create another array here. This is going to be array3 and array from. And here we'll pass in array1. And we will take each value that is inside of array1, and we will multiply it times 2, and then save it into array3. And then, of course, we're going to be able to iterate over our arrays. So I'm going to say for let value of, and I'll print out all the information for all of these. So I'll go array1, and then I want to print out some info. So we'll go array value. And then the value that we're going to print out is just going to be VAL, array from, got that. And there you can see array value 1, 2, and 3. That is from this guy right here. We can also come in and just change this into array 2 and reload. And you can see there it's cycled through all the values in that string and printed those out. And then we can also test to see what goes on if we were able to double all these values here, and we see that we did. Okay, so quick rundown of arrays, and now I want to take a look at sets. Now a set is just going to be a list of values with no duplication inside of them. So let's go random set is equal to new set, and define that guy, and then we'll be able to come in and say random set and add a value to it. So there is a 10 and another random set, and we can throw anything inside of here. So we can say throw a string inside of there instead. There that is. And we're going to be able to check to see if a set contains a value. So we can check to see, for example, if this set contains the number 10, and to do so we're going to go random set and call the has function, and what specifically we are looking for inside of it. We are also going to be able to come in and get the size of it. So let's say set size and go random set once again and size, and we will also be able to delete an item from my set. So random set again, and let's say we want to delete 10 out of there. We don't want it anymore. And of course we can iterate over all the values in a set. So we'll say let value of random set, and then we'll print all those different items out. So what would we want to put here? Maybe like set value like that, and then get all the individual values just by throwing value inside of there. And we can run this and see how it works out. You can see has 10 comes back as true, set size is 2, and right here we have set value is equal to word. And the reason why is there's only one value inside of there, because remember, we deleted the 10. All right, quick overview of sets. Now let's take a look at maps. Now a map is going to be a collection of key valued pairs, and I'm going to come in here and create one. So we'll call this random map, and you just go new map like that, and there you go, you created one. And if we want to handle or enter in a value, we can go random map set. And then we're going to define our key. I'm just going to call this key 1. Of course, it doesn't have to be called key 1. And we can throw anything we want inside of there. So I can say random string, random map again, and we'll throw another one in there. And I'll just call this key 2. Once again, for no reason, I'll throw a 10 inside of there. We're going to be able to get the values that are stored inside of there. So we can say key 1, and then we'll go random map. get, and then pass in whatever key that we are looking for, and it's going to pop that back to us. And let's go and grab the other one just to give you an example of what they both do. So we'll just change that to key 2, and that's not a problem. And there you can see random string and 10 comes back. This should be key 2, but whatever, that's fine. We're also, of course, going to be able to get our map size, the number of values that are stored inside of it. And that's just going to be random map and then size, like you may have guessed. There that is. And then once again, of course, we're going to be able to iterate through this guy. And one way to do that is with forEach. And here I'm going to go function. I want to get the value and the key that is going to be stored inside of there. Come down here, throw that there, and then I want to print out that information. So let's just keep this rather simple. I'm just going to say that I want the key, and then after that, I want the value associated with that key. And you can see it did just that. Okay, so cool stuff. And now to wrap it up, I want to talk about promises. Now, promises define code that is going to be executed later, and promises either succeed or fail once, and they are either going to have a state of fulfilled, rejected, pending, or settled. And I think the best way to understand them is to sort of see them in an action. Now, a promise, what I want to do here first is cover a promise that is handled immediately. So to create one, I'm going to go P1, and I'm going to say promise resolve, and I'll call resolve me as what's going to be passed inside of here. Then you're going to have a function, and it is called then, and it's going to take 2 optional arguments, being first a callback for success and then another for failure, but they are optional. So here I'm going to go res that, and this is going to be resolved. So we can go document and write, and then we will print out on the screen the message that we want printed out on the screen. I'm going to show you 3 examples, and there's resolve me. So this was passed, and it was caught, and it was printed. Okay, so let's do something a little bit more complicated. What I want to do now is create a promise that's going to execute after, say, 2 seconds. So let's just create a brand new one here, and we'll go P2 is equal to new promise. Once again, it's receiving a function, and we'll say resolve or reject. Close that off. And then to time it out, I'm going to call set timeout. Don't put anything inside of there. Use our arrow function. And then I will call resolve and pass resolve me after 2 seconds have passed. So that's going to be 2000 milliseconds. So then we can come down here and call the then function, and here is going to be the message passed in once again, and then we can do a document write on this guy and pass the message inside of there. And you go reload it, and then uncaught, and get rid of that, throw that there, and reload it. And you can see resolve me shows up, and then after 2 seconds, resolve me shows up. Maybe I should change the message. So resolve me 2, reload it. And there you can see resolve me 2 shows up after 2 seconds. And let's show you another one where we have a situation where a promise can be fulfilled or rejected. So I'm going to go random value is equal to 18. And then we will define our promise. I'll call this promise 3 is equal to new promise. And here we'll have our function, and it'll either be resolved or rejected. Throw that down there. And then it's going to be resolved or not resolved based off the value of the random value. So I'm going to say if the random value is equal to 6, then I want to resolve it. I want to say that this is a good value. And of course, this is just random stuff. And then we can reject it otherwise, and we will say that it's a bad value. And how we can handle this is go P3, then, and val, and document write, and print out our value in that situation. And why do I keep spelling then wrong? And then I'm going to put a comma here, and then we'll have a situation in which we get an error, and in that situation, we will print out that error. Like that, and then close that off like that. And here you can see bad value comes back because the value here is 18, and if we would change this to 18, you can see that we get good value. Another thing that's important is that you should add a catch to the chain to handle your errors always. So let's go do one more example here. So I'm going to go var p4 is equal to new promise, resolve, and reject again. And let's come up here and throw our random value inside of here just so we can have something to check against. So here we'll say random value is equal to 18, just like we did previously. And now what we're going to do is we'll say if random value is less than or equal to 17, then we want to throw an error. And what we'll say here is can't vote, which is going to work basically exactly the same as a reject. Else, we'll say resolve, and in that situation, we will say can vote. And then we'll use then once again. So we'll go P4 and then, and we'll receive our value. And then, in which we do not have an error thrown there, we will print out the value that was passed there. And otherwise, we can say catch and catch the error in that situation. And here we will print out our error message. And there we go. And reload it and see what happens. And you can see that can vote comes back. And if I would come in here and change that to 5 and reload, you're going to see that can't vote shows up. All right there, guys. That is a rough overview of a vast number of changes that have taken place with ECMAScript 6 since the previous version. Hopefully that helps you guys resolve any issues or questions that you might have. And like always, please leave your questions and comments below. Otherwise, till next time.